quick revision video on sodium thiosulfate titrations. So the first thing I'm going to do is run through the theory behind how it works. Then we'll look at some equations, some examples, and then I'll finish with a run through the practical technique. So the basis behind these experiments, these titrations, is you take an oxidizing agent, which ultimately you're going to want to know something about, so maybe its concentration, and you react the oxidizing agent with iodide ions. And that's going to oxidize the iodide ions into iodine. So you can see we've got a brown solution in the beaker now. And then we're going to take some sodium thiosulfate solution of known concentration and carry out a titration to work out how many moles of iodine were produced in the original reaction. So you can see there's the titration equation there. So from the end point, the volume used in the titration, we can work out the moles of thiosulfate ions. The mole ratio in the titration equation will tell us how many moles of iodine must have been present. And remember that iodine was produced by the first reaction, and so once we know this, we can work backwards to find out the moles of oxidizing agent and then finish off with whatever we've been asked to calculate. So I've got three examples. Now in the exam you'll always be given the equations, you just need to know what to do with them. So one of the examples I've got is the chlorate 1 ion in bleach. So a common question would be to calculate the percentage of chlorate ions in bleach, for example. So what I'm going to do is make a very important point first of all, that the iodine produced by the oxidizing agent is the iodine that features in the titration. So it's really important to get in your head that these are actually the same thing. I'm just going to make up a number, 0.02 moles of thiosulfate, and we'll just run through how many moles of oxidizing agent must have been present initially. So the iodine moles is going to be half the thiosulfate moles, and you can see there's a one-to-one relationship between the iodine and the chlorate 1 ion, and so the moles of that would be also 0.01. So in this case, the moles of ClO- ion is half the moles of thiosulfate. So another example could be to calculate the percentage of copper in a metal or percentage of copper in an alloy. So the oxidizing agent in this case is the copper 2+ ion, which is normally generated by reacting the copper with some acid. Again, that important point that the iodine in the titration is the iodine made by the first reaction. Let's feed in the same number of moles, 0.02, so the iodine is 0.01, and then we double it back up again to get the moles of copper 2+. So in this example, the moles of copper 2+ is the same as the moles of thiosulfate. So the final example I'm going to look at is this one here, the iodate 5 ion. So that's this IO3- ion. And this one sometimes catches people out because we've got different numbers in front of the I2 in the titration equation and the original oxidation equation. The important thing to keep in your head is that they are the same. So as an important fact here, mole ratios don't exist between two equations. So you can't apply a mole ratio between this equation and this one. So if we feed the moles in again, 0.02, so the iodine moles will be 0.01 for both of those equations. So then it's just going to be a third again. So in this case, the moles of IO3- is 1/6 of the moles of thiosulfate ions. Now a common mistake is going to be the student works out the moles of iodine correctly, but then trebles it when they go into this equation. You can't do that. So we'll just finish with a run through the method now. So the first thing you would do is react the oxidizing agent with those aqueous iodide ions, and that's going to generate the iodine. So that would be observed as a light brown solution in your conical flask. You then perform the titration with sodium thiosulfate of known concentration. So as the iodine reacts, its colour will become paler and paler, so it's going to go more yellow. And then when you get to a pale yellow colour, you then add some starch indicator. So at this point you're very close to the end of the titration, but there's still a tiny amount of iodine left in, so the indicator will go blue-black. And then you just add a small amount of thiosulfate to get rid of the last amount of iodine, and that is going to generate a colourless solution. So the colour change in this titration is blue-black to colourless. And I'm sure you can appreciate why the starch indicator is really helpful. As the iodine reacts away, this is going to become more and more pale yellow, so it's going to be very difficult to see the point when the pale yellow, the very pale yellow colour, becomes colourless. As long as there's a tiny amount of iodine present in the flask, when you add the starch indicator, it will go blue-black.